We did f times g of x. I'm just trying to think of how we actually wrote it. We just put a time symbol between them like this. Yeah. Fx times g of x. And then we did dividing. I'll put like division like that, which really just meant take f of x, divide g of x. So that's everything we did yesterday. I call that operations of functions because you're doing an operation, adding, subtracting, multiplying, dividing. Hopefully you did your practice. There was kind of two ilks of questions. So one type of question is you actually take the functions and add them together to create a new function. And the other questions where you took the y values and you added them together to get the new value. It's not too crazy. It's one of those things that might be confusing until it clicks. And then once it clicks, you'll probably rip through them. So if you are struggling with it, just come and ask a couple questions after class. We have Flex, right? So just come and ask a couple questions and we'll probably clear it up in no time. But if you don't ask questions, it'll just stay confusing. Today, we're going to do something new called compositions of functions. Composite functions. She's got her picture there, pineapple and pizza. I don't know, Miss Schaub's smarter than me, so I can't comprehend what that means. A composition of function is like a function inside of a function. That's how I like to look at it. So there's different types of notations. You could write it like this with an open dot. That means composition. So it would be f with g of x inside of it. So it looks like this. So instead of f of x, they changed x to be g of x. It's a function inside of a function. Yeah, you could write it the other way too. So if you wrote it like this, so g of f of x, that means f of x is inside of g of x. You could even do composite functions within itself. So you could have f of x. So that means f of x is inside of f of x. Yeah.
Can you just say like fx squared?
No, because that would be squaring x. I'll show you what it looks like, the difference, because I'll do that as a counter example of why it's not x squared. So look at this guy. You're given f of x. So f of x equals this. And g of x. G of x equals x squared. We're going to do some composite functions here. So k of x is going to become f of g of x. Normally, we write it like this, f of x. What they're saying is replace this for x in function f. So f of x looks like this. Right, that's regular f of x. They're saying change x to be g of x. So you would actually replace the value x with the entire function of g of x. So you're going to take this x value and you're going to replace it with g of x, which is x squared. So this would become x squared plus 2. It's a function within a function. I put g of x into f of x. Essentially what I did was, just see a couple people looking at me like I'm crazy. Not completely crazy. Essentially what I did was this. Right? Like I took x and I changed it to be g of x. That's what I'm doing. That help the situation or make it worse? All right, let's do another one. Okay, the next one is f of x. So this will probably help a little more. This is a better example, I think. So they want you to take f of x. Right, that's how you'd normally write it. And they want you to replace x with the function f of x. F of x normally would equal this, x plus 2. Agreed? Like that's regular f of x. Now, change x to be f of x. So change your x values to be f of x. That means x would change to be x plus 2. I replace x with f of x. And it's a function inside of a function. You can then simplify that, right? So that means f of x equals x plus 4. I feel like that's actually a better example, that second one. It like looks more obvious of what's changed. Grade 10s are bumping over there. The grade 10s are almost as scary. How do we feel? Is that like okay? Yeah. That's what we're going to be doing today. So composite functions. Functions inside of functions. Okay, so different strategies on how you can do these ones. We'll go through the different strategies together. So the first one is f of g of 5. So two ways to do it. One way to do it, figure out what this equals. Right? If you took g of x and you changed x to be 5, what does g of 5 equal? So you could do that as a separate calculation. G of 5 equals the function 5 minus 2x, but it'd be 5 minus 2 times 5. Right? Take g of x, change x to be 5. G of 5 equals negative 5. Now that you know what g of 5 is actually equal to, you could go back and change this. Instead of saying f of g of 5, I could say f of negative 5. Right? Because I know g of 5 equals negative 5. And I could then calculate f of negative 5, which would be 2 times negative 5 plus 3. F of negative 5 equals negative 7. So I solved the first function for a value, use that value, solve the second function. F of g of 5 is negative 7. Okay, that's one strategy to do it. Second strategy, if you're like, oh, I don't know if I like want to solve it and then put it in like that, is you could figure out what the composite function is. Right? So this is g of f of -3. So you could just figure out what's g of f of x. And you could make that new composite function. So go to your g function. G of x is 5 minus 2x. Change x to b f of x. So you would now have 5 minus 2 times 2x plus 3. Right? I put this in for x. This means g of f of x is 5 minus 4x minus 6. So g of f of x is -4x minus 1. So I put f of x in for x of g of x. Right, there's my replacement. I multiplied the -2 in, you get this. And I collected like terms. 5 minus 6 is -1.
So when you're using the first strategy, we're like inside to outside.
Yep. Yeah, you're like solving the inside and working your way out. If you do this strategy, you've created g of f of x, and now you can go ahead and change x to just be -3. Right? So now if I wanted to know what's g of f of -3, it would be -4 times -3 minus 1. That means g of f of -3 is equal to 11. Both strategies are legitimate. The left one's probably easier, in my opinion. But you could do the middle strategy, like the one on the right as well. Like you could change the two functions and then calculate it. It's kind of up to you, like to each their own. Yay? Nay? Okay, so this one, I don't have nearly as much space. You're so loud. No. Hey. Yes.
Yeah. Yeah, I do agree.
Thank you.
Yeah. You should have sent me a book. Oh my gosh.
I'm not even close to basketball candidate.
Yeah.
You should have thrown a chair.
I didn't punch a locker. We're okay. The chair one. I broke a chair. I didn't break a chair this year.
Not this year. You did toss it. You threw a chair.
I remember you kicking a chair as you left the gym, and it really flew. It
really
flew.
It didn't break. I just slammed a chair. I was angry. Yeah, it was a slam of a chair. I didn't break it though.
Why did you kick a chair?
Basketball King is a different human. Did I throw a chair? I didn't throw a chair. I didn't kick a chair.
Grade 10 at Strathmore. When I was in grade 10 at Strathmore, I came up for that tournament.
Oh,
Our final game.
I booted that chair.
Yeah, straight onto the middle of the court.
Yeah.
What?
Yeah, I did. Yeah, that's right. That hurt my foot. I forgot about that one. Yeah, never mind. I did kick a chair. The one that happened to H.A. Cody was an accident. I did not mean to hit that chair. The one at H.A. Cody, I did not mean to. I stood up and I pushed the chair and it flipped. I did not mean to. The one in Strathmore, I gave that one the boot. That was like, I was angry. My inner Bobby Knight came out. Do you guys know who that is? Oh, this is recording. What I would do is I would figure what f of 0 is. Yeah, like f of 0. Oh, it's tricky on where to do my work with that thing there. I would go f of 0 equals 2 times 0 plus 3. Right? That's taking function f, changing x to be 0. That means f of 0 equals 3. That means I can go to the next step of this and solve for negative 2g of 3 because I know f of 0 equals 3. Then I could solve for g of 3. So if I solve for g of 3, it would be 5 minus 2 times 3. G of 3 equals negative 1. Then I could move on to solving negative 2 times negative 1, which is equal to 2. All right, like inside out. I think that's honestly the best, most effective way to do it. This is a legitimate strategy. You know, those questions where it's like, hey, find the mistake. That's a strategy that's sound mathematically. This one's probably easier. Right? So if that's a test, that's how I do it. Solve, plug, solve, plug, solve. Feel good? Okay. Looking at this one, so given that f of x equals x squared plus 1 and g of x equals root x plus 3, determine the composite function f of g of x. Don't worry about state the domain range. We'll talk about that after. They're asking you to take f of x, replace x with g of x. Right, like that's what it's saying to do. So f of x equals x squared plus 1. Change it from x to g of x. So change x to be square root x plus 3. You see how I've changed the x value to become the square root of x plus 3. X changed, everything else, the square, the plus 1 is all still there. That's composite function, function inside of a function. You could simplify this, and you should. So this should simplify. Right? If I have the square root of something and then I square it, those will cancel out. So I really have x plus 3 plus 1. That means f of g of x equals x plus 4. For sure. Are we good with the composition there? Like that composite function. Function inside of a function. Yeah? It's clicking now, hey? I see a lot more nodding and like, oh, okay. Like, function in a function. Let's talk about how to do domain and range of that, because that is tricky. So now that we know what this equals, x plus 4, we could do the domain and range. I'm going to do a quick sketch. So if you were to graph this thing, let's just do like tens. Your graph would look like this. You'd have a y-intercept at 4. And you'd have a nice not horizontal. You'd have a nice diagonal line, something like this.
Wait, are we supposed to draw this?
Yeah. Don't worry so much about anything beyond getting that x-intercept right.
What's the answer?
Or the y-intercept right.
Right.
Yep, it goes forever left and right. That's why I have arrows on my red line. Yeah. So you should sketch that just so you know what we're going to refer to here in our notes. This function is f of g of x. That's what that line is. Agreed? It's x plus 4. Cool. If you did domain and range of that thing, it's pretty easy. The domain is forever to the left, forever to the right. The range is forever down, forever up. Right. So like this would be x, y, essentially. Cool. That's if it was a normal question. This is not a normal question. This is a composite of functions question. It's kind of like, throwback to Math 20-1, we did NPVs in rational expressions, right? And we said you had to do your NPVs first before you did any simplifying, right? Because if the original function was dividing by 0, that means the actual function was also dividing by 0 at some point, and it's not allowed. All right. That same kind of knowledge is going to apply here. If you look back at the original functions, there's certain x values that are not allowed. So look back at g of x. We know that g of x, I'll do this down here. We know g of x equals root x plus 3. X can't be any number. Why can't x be just any number? Can't root a negative. Right? That means there's a restriction on this thing. The restriction is that this thing has to be bigger than 0. Right? X plus 3 must be greater than or equal to 0. It must be. Otherwise, it would be negative, and you can't root a negative. If you move the 3 over, that means that x must be greater than or equal to negative 3. You can't see what I'm doing. Oh, there we go. Right? If I move the 3 over, I get that as my new restriction. This restriction still applies to this function. Because you got to remember that x plus 4 actually got simplified. It came all the way from up here, right? And if x was anything less than negative 3, we would have been rooting a negative way back at the beginning of that stage. So our domain from the original functions will affect the domain of our new function. So our domain for this question, I'll do it in blue. Domain is square bracket negative 3, comma, infinity. That means the lowest it can go is negative 3. It can go up into infinity. To close that off, I close it with a square bracket. Does she say it has to be round?
Yeah. Because you can never reach infinity.
You can't equal infinity, but you can equal infinity. I'll go round. It just doesn't look as pretty. I wonder if it's wrong if you square it. I'm going to ask her. I wonder. Yeah.
So I was wondering, I don't know why this is hitting me, but like, so if you were to use a square bracket there, it's a little bit weird. So like, when would you put a round bracket? What can you not equal besides infinity?
That's what I'm saying. I think you could put a square bracket on infinity over there,
But, like,
and it would still be
you
right.
have-
But that's just
there-
saying calculus is
Like,
no.
there is round brackets.
No,
so like,
it's-
what would you have to have?
So, like for instance, say this was x is greater than -3, and it couldn't equal -3.
Oh,
That's a round
I
bracket
see.
situation.
I see.
And if it's infinity, it's around bracket.
She's dead set on that in calc. Then we'll trust her. We'll say it's a round bracket if it's infinity.
You can't.
There's a round bracket
in front of the negative
three, would just mean
no
equal -2.
It goes further.
Yeah. So it's a good clarification question. Gentlemen, boys, Matthew, boys. The question was, if there's a round bracket on -3, does that mean it could equal -2? It could, but it could also equal -2.99999. It could equal anything all the way up to -3, but it can't equal -3. So it's like it gets super close, but it doesn't actually reach there. So round bracket means as close as you can possibly get, but not equal to. Okay. The range. Normally, this range would be YER, up forever, down forever. Negative infinity, positive infinity. However, we have a restriction on this thing. That restriction is that you can't go past -3 in your x values. So you need to go on your graph and find where x equals -3. We know that x equals -3 here at -3, 1. The reason I know it's there is because if I put -3 into this, -3 plus 4 is 1. So -3, 1 is our point. And I cannot go left of that.
Sorry, how do we know it's -3?
So if you use -3 for your x value, -3 plus 4 equals
Oh.
1. That's why it's -3, 1. That means that the lowest my range ever goes would be 1. And then it can go up into infinity. You use your domain to figure out your range.